So here is problem number 15 from section 5.4, and they're asking, given this, will you please find out what is dy dx?
Alright, so you have to make a negative.
All right. Well, a couple of things are going on here. We know that in order to get this side to equal dy dx, we're going to have to take the derivative. And whatever we do to one side,
We have to do to the other.
we have to do the other. Now, when we take the derivative of an integral, it would be nice that we could be able to apply fundamental theorem of calculus part 1, which involves having an integral expression with an variable expression as the upper bound. This expression does not have a variable upper bound. It has a variable lower bound. So what we're going to do is we're going to do a little rewrite. If we change the order of integration, we put a negative sign in front of it. And now that looks like an expression that we can take the fundamental theorem of calculus, apply fundamental theorem of calculus part 1. So let's go ahead and let's take the derivative of both sides with respect to x. And dx, and I'll remember there's the negative sign. Are we okay with that?
Yeah.
All right, so I take the derivative of y with respect to x, I get dy dx. Now, taking the derivative of some expression with a constant out in front of it,
Take the constant
cancel the constant out, and now I'm left with the derivative with respect to x of the integral from 5 to x cubed of cosine t, t squared plus 2 dt. Now, what's the mantra for fundamental theorem of calculus part 1?
Function defined at u, chain rule.
Okay. Function defined at u. Okay, so we're going to take the u, which is the upper bound function.
Right. Oh yeah.
And every place that we see a t, or the variable of interest, we're going to replace it. So this is negative of cosine of x cubed all over x cubed squared plus 2, and then followed up with the chain rule,
2x or 3x squared.
3x squared. So get a negative out in
I
front.
left out the squared.
I don't know what you're talking about.
Neither do I.
Okay, so we'll get negative 3x squared cosine x cubed all over x to the 6th plus 2. Now does that have the convenience of actually being the right answer?
Yes.
Oh. Good.
Yes, sir.
Okay, so we give ourselves a check mark, pat ourselves on the back, and go on to the next problem.
Hold on.